Hi all, welcome back. This video will cover on find the number of permutations of R objects from n different objects. Now for this case, the number of permutations of n different items taken R at a time is npr, where npr is equals to n factorial over n minus r factorial. So for this case, there are two types. So the first one is with restriction, where repetition is not allowed. And the second type is with no restriction. So that means the repetition is allowed. Okay, so for with restriction, the formula that we are going to use will be NPR. For the repeated case, no restriction, so here the formula that we are going to use will be n to the power of r. Okay, so for NPR, note that the value of r must be less than or equal to n. It cannot be bigger than n. So for example, we can write 9p8 or 9p9, but 9p11, this one is not possible. Okay, so remember, r must be less than or equal to n. For example 6, in how many ways can the letters H, S, A, M and R be arranged without repetition? So without repetition means can only be used once, when all the 5 letters are taken at a time. So we need to arrange all the 5 letters. Okay, so here H, S, A, M and R, we have n equals to 5. Okay, so for part A, to arrange all the 5 letters, so here R is equals to 5. So that means we can use 5p5, or we can also use 5 factorial, and the answer that we get will be 120. So now we look at B. We need to arrange 4 letters that are taken at a time. So now our R is equals to 4. So N is equals to 5 and R equals to 4. That means 5p4. And 5p4 will be 120. Okay. For part C, now we want to arrange 2 letters. So for 2 letters, R equals to 2. So that means 5p2. The answer that we get will be 20 ways. Let's look at example 8. So for this question, how many 3-digit numbers can be made from the integers 2, 3, 4, 5 and 6? And here I'm going to write n equals to 5. Okay, 2, 3, 4, 5 and 6. And our r will be 3. So 5 integers to be arranged as a 3-digit number. Okay, for part A, each integer is used only once. So only once means no repetition. The way of answering the question will be 5p3. So remember, if no repetition, we are going to use NPR. So 5p3 will be 60. Okay, so let's move to question B. There is no restriction. So if we look back on our notes, no restriction means we can repeat. So for this case, if yes repeat, so that means we want to arrange 3-digit numbers from 5 integers. Okay, so 1, 2, 3. So on the first place here, there will be 5 possible integers. So it will be 5. So since we can repeat, if we have already used, let's say, integer 3 on the first place, so we can still use it on the second place and the third place. So that means if this will be 5, so for the second and the third place, it will be repeated as well. So 5 and 5. So this results with actually 5 to the power of 3, and the final answer will be 125. Okay, so I repeat. So for no repetition case, we are going to use NPR, and if repetition case is allowed, so we are going to use N to the power of R. Okay, so R represent the position that we are going to put, and N here represent the total objects that we have. Okay, now let's go to the final example for this video. Example 9. 4-digit numbers are to be formed from the digits 0, 1, 2, 3, 4, 5, 6. So 4-digit numbers, that mean our R is equals to 4, and here represents our N. So N will be 7. So the numbers do not start with digit 0. Okay, so if the numbers start with digit 0, that means it will not be 4-digit number. It will be 3 number, right? So for example, let's say we have 4 place. So if we put 0 at the front, and let's say 2, 4, 3. So the numbers that is formed here is actually just 3-digit numbers. So that's why 0 is not allowed on the first position. So now, how many numbers can be formed if the number is less than 5,000? Okay, for both part A and part B, the number that we need to form must be less than 5,000. A, every digit can only be used once, and for part B, it said can be repeated. Okay, so for number that is less than 5,000, if we cannot repeat the integer that we use, so that means for part A, if the number is less than 5,000, so it does not include 5,000. Okay, so the only number that we can have will be less than that. So for this case, okay, for the first digit, the possible digits that we can put in the first position here will be 1, 2, 3, and 4. So remember, 5 cannot be included, okay, because it will be larger than that. So 1, 2, 3, 4, that means we have 4 possible digits. Now, if I choose digit 2 to be written on the first digit here, that means digit 2 will not be used on the second, third, or fourth position. Okay, so we need to cross digit 2. So now we only have 0, 1, 3, 4, 5, and 6. So that means for the second position, there is only 6 digits left. And if we have choose one number from this possible digit or possible integers, that means the only digits left for the third position will be 5. And for the final position will be 4. Okay, so what are we going to do with all these numbers? We are going to multiply all of them. So this is actually the same as the boxes method. Okay, so here we have a total of 480. So actually, these numbers here, 6 times by 5 times by 4, we can also written as 6p3. So why 6p3? Because we have 6 remaining digits left that need to be arranged at 3 position. So the alternative way we can write is 4 multiplied by 6p3. Okay, now for B, 4 position, and the first digit here will be 4 possible of ways. Okay, so because we can write either 1, 2, 3, or 4. So let's say if we have choose 2 to be written on the first position there, so 2 can still be written on the second, third, and fourth. Okay, so it can be repeated. So now what will be the remaining digits to be written on this 3 box. So we have a total of 7 digits. So that means this 3 box, it will be 7 to the power of 3. Okay, so we can have still 7 possibilities. 7 possibilities of digits and also 7 possibilities of digits. So we can write our answer as 4 multiplied by 7 to the power of 3. And the result is 1372. Okay, so hopefully you understand this case or this lesson. If you have any difficulties, so you can repeat this video. Thank you.